The International Space Station is home to many experiments that are looking into how the weightless environment in low Earth orbit impacts the human body. This is with an eye toward resolving the issues that could affect explorers on long journeys well beyond Earth in the future. One such experiment, which is focusing on stiffening of the astronauts' arteries, is known as Vascular Echo. And this morning we're going to find out more about it from the principal investigator, Dr. Richard Hughson of the Schlegel University of Waterloo Research Institute for Aging in Waterloo, Ontario, Canada. Good morning, sir.
Good morning, Pat.
Dr. Hughson, let me start by setting some of the groundwork for me. Tell me, what is it that causes arteries to stiffen, and what is the problem with that from a health standpoint?
Okay, well, on Earth, I think we all know about arteries getting stiff as we age, and the problems there are somewhat different from spaceflight. Some of the causes we can talk about in a second might be similar, though. People with hypertension, but also as we age on Earth, the elasticity in our arteries, the elastic tissue starts to break down. That causes stiffness. When you get stiffer arteries, unfortunately, it doesn't buffer the energy that's put into the blood as it's being ejected from the heart. So if it doesn't buffer that energy gets transmitted into some of the smaller blood vessels, and especially the brain and the kidney, where they're very high flow organs. You don't have that buffering, and you get a real high impact of that energy on the smaller blood vessels. It starts causing damage, can lead to problems up to and including dementia, and perhaps Alzheimer's is part of that as well. But certainly you can have a lot of damage to these organs if you have that lifelong exposure.
Now, astronauts are relatively healthy and relatively young, in fact. How does an expert on aging get interested in using astronauts as research subjects in this area?
Well, I guess it really goes back to my interest in the benefits of physical activity. And ever since the shuttle days, when astronauts often went up for maybe a week or two at a time, and many of them were unable to perform really more than very minimal activity up there, exercise that's because otherwise they're floating around in the shuttle or in the space station now. So that the level of activity is greatly reduced compared to what we do here on Earth when we have to work against gravity. So if you take away the daily physical activity and you now have them floating, when you introduce exercise, the question is that enough? The answer that we've come up with, we just finished a study that was called Vascular, before the Vascular Echo study. And in Vascular, we documented that astronauts are actually doing only about 30 minutes per day of aerobic type of exercise, plus what they do on the ARED. And we know on Earth now there are many studies starting to appear showing that if you went to the gym in the morning but then sat at your computer for the rest of the day and did no physical activity, you do start showing signs of signs of change that include arterial stiffness, also include insulin resistance, and the potential for developing type 2 diabetes. So inside the vascular study, we also measured insulin resistance and documented that astronauts do have an increase in insulin resistance. Now, they're not type 2 diabetics by any means, but they're going in that direction and showing us just how important daily physical activities really are.
So in this case, what is it that you're having the astronauts do in order to gather data to assist this research?
Okay, in the vascular echo study, we are collecting some blood samples so we can look at those biomarkers, but the major focus is on using ultrasound technology to look at the arteries. We also look at veins and the heart, but the focus on the arteries, we can image the artery as it's expanding with each heartbeat, and we can determine, is it expanding as much for a change in blood pressure or less? And certainly in the vascular study, we saw that it was expanding less, so it is a stiffer artery. And we're really focusing in on the carotid arteries as being the primary place that we expect to see this. The reason for that, I mentioned earlier, hypertension. Well, astronauts are in effect hypertensive from their heart up to their head. As you and I are sitting here right now, the blood pressure up in our head is as much as 30 millimeters of mercury less than it is at heart level.
Because of gravity.
Because of gravity, yes, because you're having to pump up against gravity. So the hydrostatic effect takes away some of the pressure as it's going up. In space, that pressure stays the same throughout the body, up to the head, all day long, 24 hours a day. So they are in effect then hypertensive in the head region compared to what we normally experience on Earth.
So are there any initial thoughts about the ways that this arterial stiffening can be prevented for astronauts, which in fact might be able to help the rest of us too?
Yeah, well, there's not much they can do about that change in the hydrostatic pressures. Their blood pressure in the head is going to be higher. Physical activity, 30 minutes per day in one session probably is not enough. So, if you start talking about exploratory missions back to the moon and to Mars, people are going to have to exercise more frequently throughout the day. And we hope that that's going to be of some benefit. Nutrition is perhaps a thing that can be worried about as well. Certainly the insulin resistance that we detected could mean that high glucose levels are happening. If you have high glucose levels, you can have formation of cross bridges inside the vascular smooth muscles walls. And those cross bridges can introduce stiffening. So we want to try to avoid that. So again, the best we can do is sort of maintain good physical activity, good nutrition, try to avoid those high glucose levels.